Keith Harrington here, KQ4 FXD. Before we get into the video I've done on an antenna that I built, a 6-meter antenna, I'm going to go over a few things to make sure that you follow close attention to everything. A lot of you have decided to move more into 6-meter communications and ham radio. I myself chose to do the same thing. There's several antennas that you can get for 6-meter verticals, and then there's one called the Moxon antenna. And what I've done, I've kind of followed the same dimensions pretty much of a Moxon antenna, but I've used different materials to accommodate that. A typical Moxon antenna is an antenna that uses wire, and it's pretty much expanded out with using PVC pipe that's flexed. It keeps the wire really tight around the whole antenna, and it works. It's very effective. It does a good job. I wanted to build one of my own design, and I haven't seen anything online close to it, but there may be. I just didn't look hard enough, maybe. But I'm making an antenna. Well, I made the antenna actually using a copper tube, 3/16 copper tubing, typically used for brake lines and other applications. But this tubing is coated in copper, which is a higher conductivity element than aluminum and some of the other metals that's out there. So I chose to go with the copper coated tubing. And unlike a Moxon antenna, this is not flimsy like a wire would be where it'll fall, but yet it will bend. You can bend this. So you have to take some other things in consideration when building an antenna of this design. You have a driven element, and you have a reflector, pretty much like most antennas. And you have to keep some things in perspective when you're building one of these antennas. Same way with the Moxon antenna with wire. Same thing. You have to keep spacing correct and distance of length of wire and all like that. With this tubing, you're going to follow the same principles, but it hooks up to the antenna a little different way. Instead of having elements that stretch out and pull it tight and keep the wire tight like on a Moxon, this actually has to have some paracord or wiring that goes into these insulators I built with my printer. I printed with the printer and designed, and I'll have them in the build where you can download the G code for that and build your print your own. But these actually, a paracord will go in here and go to the center mast and keep these elements rigid, so if a bird or something lands on the elements, they won't bend over time, because you get enough weight on it with the 83-inch span, which the reflector and the driven have a long span at either side, where there's a lot of length there. So even though it's pretty rigid, if a bird lands on the end here and you don't have anything to support that, over time it's going to eventually bend, and you're going to get a bend in your antenna, and then it's not going to work as well. So you want to keep it as straight as possible. So my design is pretty much you build the antenna. Of course, the tube has to be straight and built straight, so it keeps its shape for the most part. And then you'll put your rope on here that goes to the center mast and supports these long sections and keeps them from bending down. If a bird or whatever lands on it over time, it starts bending down. You don't want that. And I'm only using 3/16 pipe, so even though it's still rigid, it will bend if you get enough length on it. It'll bend, of course, with leverage and everything. It's gonna eventually bend, so you don't want that. And that's all covered. That's covered in the video. The main thing I want to talk about is these corner connections that I actually design, and you can print yourself. aren't necessarily needed. I built these in particular so when they're put in place, you have a good solid point to tie your cord to. I put a hole in here, so you put your paracord in there, and it goes up to your mast and gives you that guy line, that guide that kind of keeps it from bending down as it pulls against that center mast. So it makes it rigid. So that's why that's there. You physically could hook a paracord here and just tape it up or something, keep it from sliding down the tube, and do this the same way without these corners. That's totally up to you. One thing I will say that's critical is having some kind of a design in place, whether you use PVC pipe as a spacer or you print these tubes I have here. And basically what you have is incorporated in these pieces here. You have a 3-inch solid place inside here. And you have an 1.5-inch hole that allows this tube to go in 1.5 inches. So when you put this tube in there, into here, it goes up in there 1.5 inches. But what I recommend before whatever you decide to use, whether you print these or you use just a hollow pipe all the way through, is that you mark these 1.5 inches and put a marker on it. So when you insert this into your tubing, that when it goes all the way in and bottoms out, that it bottoms out on that line. That line you mark on there for 1.5 inches. You got to maintain the distance, so you got to make sure that whatever distance from the reflector and the driven, that you have 3 inches. You got to have 3 inches in there. If it's not 3 inches, it's not gonna you're not gonna have the right resonance. It's not gonna resonate correctly, and it's not gonna work correctly for you. So you gotta remember that 3-inch gap in there. Okay. And it's in the drawing here, and I'll put that up there. You got a drawing here that shows the 3 inches. You got 3 inches in between the reflector and the driven. So also make sure that you pay attention to your reflector. Your reflector is going to be a little longer. The tubing is going to be longer than the driven side. You're going to have 15.5 inches on your bend on the reflector. 15.5. So when you make your bend, that distance before it gets to this, the 3-inch gap is 15.5 inches on the reflector on both sides. On the driven side, it's going to be 12 inches. You're going to have a 12-inch bend. So just make sure you're consistent with that, and you follow the diagram, and you put the right lengths to all your components. So even though I'm showing this in the video, a longer piece, whether you make it yourself out of PVC, which is great, make one out of PVC or plastic or whatever, and make it long enough so when you tie your tube in, put your tube into this, where your wiring is going to go for your driven, you got to have this for all your coax. Your coax will hook to this. You got to make sure you build that where it's very rigid and it's not gonna bend, because this design the way this is made right here, bad design on my part. When you put it in place and you put your straps on there, you can see you only got maybe an inch that holds this. You got 2 straps right there. I that was a bad judgment call on my part. But anyway, it will bend, even though you got straps there. It will give. You'll have some giving points. So when it's all said and done, you'll have your driven element getting a bend on you from both sides, and you don't want that. You want that to be as straight as you can, nice and tight, so it keeps this element good and solid. So anyway, I will incorporate that. I'm going to redesign that and put that in the video. Anyway, that being said, go ahead and watch the video, and you be the judge. And if it's something that works for you, good luck. And it's very cheap to build. The whole roll of this, 25 foot of it, is only $9 and some odd cents, less than $10 for the pipe. So that's a very good price. These, if you do any printing at all, these are very inexpensive to print. You're talking pennies to make one of these. So everything that's probably the most costly part to the whole thing will be the tube, about $10, and then your PVC. You'll need some PVC pipe, 1/2 inch, some T's, and a four channel connector, 1/2 inch connector for the PVC pipe. Um, that's not a whole lot of money either. Probably less than, I'll say less than $15. I can't remember what they were. Not that much anyway. So you're probably looking at overall maybe $25 for parts. So if you can build an antenna, 6-meter antenna for $25, it's a pretty good deal. Plus your cable. If you got some cable laying around, cable's probably going to cost you equal to that. So let's, I don't know what you're going to have, whatever you're going to do to finish this up and to run your coax. The cost will be whatever you need distance-wise of coax to get it from the antenna back to your radio. So however you accomplish that, that'll be a cost you'll have to figure in. But the main antenna parts, $25 is probably what you're looking at. And the coax, of course, will be an extra cost depending on your application. So anyway, let's get to the video. Thanks for watching this first part of this anyway. And I'm Keith, KQ4FXD. Good luck with your 6-meter build and have fun. I want to show you a quicker way to do this. When you're putting in these corner brackets, if you start your bend, just take your fingers and make the bend here, put your thumbs in the middle. And once you get it close to where you want to be, you stick it in one side, and then you're going to take and literally pull this corner over, pull the other corner over to your bend, like that. And that'll allow you to push it in place, like that. And then you can straighten it back out. And then we're going to go ahead and fill it with glue and put our cover on it. Okay, this is going to be similar to the Moxon build, but like I'm saying, we're using tubing, and it's going to be, instead of being inverted upward, it's going to be straight. And I'm going to show you the rest of the stuff here in just a minute. So we're going to go ahead and get this glue gun heated up here. Let's get in there. Okay. And what we're going to do, we're going to put glue in here, and then we're going to put this little cover on it. And we're going to do that to each one of the corners as we go along here. So I'm going to show you once, and then I'll show you the final product. Then once you fill it with hot glue, put your cover on it, it's going to look like this here. Okay, then your rope's going to go in here, your paracord's going to go here, and that's going to hook to the top of your mast. And that's what's going to keep this raised up in its position. Okay. And don't forget, when you're connecting these pieces, you put all your pieces around before you connect. Like before I connect this to the insulator, I got to make sure I put my PVC piece in there. Otherwise, you won't be able to get it in there. Okay. So make sure you put everything on the antenna as you're going along, so you don't miss something. Okay, that's what it looks like. Okay, there's one done. That's the corner. Okay, and we're literally everything I made up here. We'll finish this antenna out, and you do all the corners the same way. Now, one thing I haven't done, I haven't showed you, and we'll do it with this piece if I can pull it around here. It's very, very long, and let's see if I can get the camera around here where you can see it better. And let's get this. This has got to be bent too. I've got to put some tubing in here. One thing we have to do that we haven't done yet. Okay. We've got, of course, the bend here. This is the reflector side, and these are the tubes. These are the tubes here I made. Let me get it down here where we can see it better. These tubes are I made them in such a way. There's a 3-inch solid section that's down in the middle, so you can have literally an 1.5-inch insert. So the tubing will go in there 1.5 inches. So what I usually do is I measure 1.5 inches on the end. So when I'm shoving it in there, I make sure it bottoms out where it's supposed to. Shrink tube will seal this so it doesn't pull out. Okay, now we're going to go ahead and measure this. This is part of my driven side. It's going to go to the reflector side into the insulator. So what we want to do, we want to measure. Although I have a stop in there in this piece here I have a 3-inch solid piece in the middle that stops this going into only 1.5 inches. Okay, we're going to go 1.5 inches right there, and we're going to make a mark. Okay, so we've got a mark right here, 1.5 inches. Okay, so that's how far this has to go into this tube, this insulator. Just make sure you got it on there before you shove it in there so you don't have any problems. Okay, or shove the pipe in there into the insulator, and when it go right up that line, and see it's already bottomed out. It's bottomed out on me. So I'm just going to push it a little bit, make sure it's right there. That's where it's supposed to be. So we're going to put this back up on there. Shrink tube. And this just holds that, keeps that pipe from coming out, keep it in place, and that's what you want. Then I'm going to take the torch. We're going to go ahead and do the this here. One thing I want to do here to make sure that nothing moves, we're going to go ahead and cut these pieces of tape so they got a nice edge on them. And it's just to keep the tube from working its way out from the center. Do the same thing here. We're going to grab the end of the shrink tube, pull it around tight. Okay. All right, and that's done. Now, what I talked about earlier, and this I need some extra support from the center mast. This being the longest distance, being that it's literally 83 inches from here to the other bend, there's a lot of ways that this can wind up needing support, and also the ability to keep the mast to keep the antenna somewhat in its position. And the other fact that I've got it driven over here, we're going to have a electrical connection on the opposite side over here. I need to figure out a place to put these T's. And I think the best place is to go ahead and put it right here. And I don't know exactly how to support these in the best way. And I'm probably gonna wind up filling it or taping it with something to keep it from sliding. But it's going to be basically in the center, and there'll be a pipe here that goes to a T. Okay, I'm going to move to the other side and do the exact same thing I did here, and taping it and insulating and all that kind of stuff. Getting the other end done and my bends in place, just like I showed you that one bend. And without boring you with all the bends, that's what I'm going to be doing. So I'm going to go ahead and shut the camera off and get to that. Okay, we're going to go ahead and join the driven together and get it ready to put our connections to. I'm going to go ahead and get my soldering iron ready here. These two pieces right here are my driven lines. One's the center and one's the shield. And this little piece I made here, it's going to go just like this here. And then we're going to secure them. And first of all, we're going to go ahead and put this wire has to be soldered into the end of this tubing. So we're going to go ahead and get that ready to go. And I'll start with that one first. Don't want anything dropping on my carpet. It's not the greatest carpet, but I'd save me having to do any damage to that. Okay, so we're going to go ahead and solder this lead into the end of this tubing, and it's going to go down through the hole, through these holes in here, and make it wick a little bit better by having some flux on there. So let's do that first. Okay. All right, now we should be good. What I'm going to do is I'm going to go ahead and do it here like this, and then we'll cut it because we gotta bend them and everything anyway. That'll hold it in place for me while I make this connection. Okay. Copper stays hot for a minute there, so just be careful with that. Don't get burned in the process because it definitely stays warm. Okay. So what we're going to do, we're going to go ahead, I'm going to hardwire this to my antenna leads. Still warm. Make sure that's good and tight. Okay, what we're going to do, I'm going to bend this down. By the way, this is number 12 gauge wire that goes inside the pipe. So in case you're wondering what gauge that is, 12 gauge is what I'm using here. I'm going to bend that down like that. And then it's going to go right here in this little hole in the center. Okay, just like that. And then we're going to go ahead and strap it. All right, there's one down. We'll cut the excess off here in just a minute. Okay, now we're going to go ahead and get this piece. Okay, we're going to bend this one down like we did the other one. Well, that see right here, that one didn't bond good. That's why we go ahead and test it with needle nose. Once you bend it, you'll know if you got it or not, because it'll pull loose. I didn't get enough solder on that one, so we're going to do it again. I'm looking here at the data points. from what I can see here, the antenna is a tad long because my SWR is coming in at 50.1990. I've got 1.8. Not critical. I mean that's still doable the way it is, and I think for the most part it'll still serve its purpose. But I would like to get a little closer to one to one. Let's see here. The minimum SWR is 1.3. Whether I can say it's better than a Moxon, I don't know. I need to compare it to one, and I need to kind of match it up as good as possible so they're equally matched, and see what kind of gain I got. But I think for the most part it will do the job, and I've got I got auto tune on this 7300, so it'll definitely get me where I need to be. And for the most part, I think it'll work. I have talked to a few people on 6 meter, and it seems like it's working okay. Not 100%, but it's working okay. So was the build good? Well, I enjoyed the build. I enjoyed it. It was fun to make. Did I learn from it? Yes, I did. Learned some things I won't do next time. I still I'm going to go out and get some pictures with the drone to kind of show you some shots from up a little bit, so you can kind of see it at different angles, and show you how the build turned out. It was a good build. It was fun. It was a fun build, and I did enjoy it. I am going to put this graph up on the screen here so you can see it, and it went pretty well. So yes, the antenna was a tad long. I need to shorten it a little bit to get it back down to as close to one to one. The range that it's out, is it critical? Well, not really. It's not going to burn my finals up. I'll put it that way, and I'll be fine. I am running on a 7300 ICOM, which will trim that and tune that a little bit for me to get it back into tolerance. The little bit that's out, but it's not that critical anyway. I'm not concerned with it at all. If you enjoyed the video, please give it a like, and please join us on our Tuesday meetings. Our next meeting will be this coming Tuesday. We do have guest speakers and things that come up that will help you learn, and please join us if you can. Thanks for watching again. My name's Keith, KQ4FXD. Have a great day.